Suppose that a casino offers the game described here. So the idea is you flip a coin, and if heads comes up, you hand over €3, and if tails comes up, you get €2. Would you play this game? Well, most people will say straight away this looks like a bad deal. You're losing more for heads than you're winning when a tails comes up, and that seems, intuitively anyway, to be a bad deal. But we'd like to be a bit more precise about this because, okay, this game, it's fairly easy to see that it's a bad deal straight away, but in more complicated games, it might be hard to see straight away whether it's a good or a bad deal. So in this lesson, we're going to examine a concept called expected value, which allows us to analyze situations like this and can often help to make good decisions. Before we get down to the theoretical explanation of what's happening here, let's use Excel to simulate what might happen if we play this game. So here's an Excel sheet that we've set up to simulate this game, and we have various columns here. Over here in column H, we have the coin flip. We're going to use Excel to generate results of coin flips here. And over here in columns A and B, we count the number of heads and tails that we've got. And here we have the winnings for heads, and then the winnings for tails go in here, €2 winnings for tails. And this column counts up our total winnings here. We'll get to this one in a minute, the average winnings. Okay, so let's play the game. So here we've got Excel to flip the coin to come up with heads, and it gives us our total winnings of minus €3. We lost €3. And we can get Excel to play this game a few different times. So drag this down. Here we've played the game 6 times, and we've got 3 tails and 3 heads, and we came out to a total winnings of minus €3. Let's play it again 6 times. So we did it again, and we got 4 heads and 2 tails. So that meant that we ended up with a total winnings of minus €8. In other words, we lost €8. And we can keep repeating this as many times as we want. Okay. So now let's do this a large number of times. So I'll scroll down here. Let's say down to, we've played the game 137 times. So we ended up getting 82 heads and 55 tails. So we lost €136. And let's play this again 137 times. This time we lost €111. And again. This time we lost €66. So you can see if we keep playing the game 137 times, the amount that we win or lose changes a lot. Right? Do it one more time. This time we lost €56. So it keeps changing. There doesn't seem to be a pattern. But where there is a pattern is if we look at the average winnings per game. So let's do it an even larger number of times. Let's play, say, about 1,000 times. Okay, so we've played 1,039 games there. And our total winnings was minus €562. So we lost €562. If we do it again, our total winnings was minus 557, and so on. This time we lost €662. So this figure keeps changing every time we play. But look what happens to the average winnings. It's minus 0.55 that time. Minus 0.498. So the average winnings, remember, is the total winnings divided by the total number of games. So the average winnings per game doesn't seem to change that much. It changes a bit, but it's always staying around minus 0.5. Minus 0.421. There, minus 0.584. And it seems to be roughly around minus 0.5. So even though the winnings change every time we do this, the average winnings don't seem to change that much. So let's see if we can explain what's happening here theoretically. So let's say that we play lots of games. So how would we work out what our total winnings are? Well, what should it be? Well, every time we get a heads, we lose €3, and every time we get a tails, we win €2. So what do we have to do? We count up the number of heads, so it'll be the number of heads times minus 3 plus the number of tails times 2. So that will be our total winnings. And now if we want to work out the average winnings per game, we just take this and divide by the total number of games. So we get that the average winnings per game will be this expression here. It's the number of heads times minus 3 plus the number of tails times 2, all divided by the total number of games. The thing on top here is our total winnings, and then to get the average winnings we just divide by the number of games. But now we can split this up into two terms. So instead of having this single term here, we can split it up into two terms, and we have the number of heads times minus 3 over the number of games plus the number of tails times 2 over the number of games. And now we can do one other step. We can take these fractions and rewrite them like this. We can take the number of heads divided by the number of games and then multiply that by minus 3 and do the same for this other term over here. Now, why have we done all this algebra? Well, the reason we've done this is that this thing inside the brackets here, the number of heads divided by the number of games, we have a name for that. That's called the relative frequency of heads. So this right hand side here becomes the relative frequency of heads times minus 3 plus, and the same thing works here, the relative frequency of tails times 2. So let's recap here. What we've shown is that the average winnings per game, when we play the game lots of times, is the relative frequency of heads times minus 3 plus the relative frequency of tails times 2. Now, here's the key step. Remember that in the long run, relative frequency becomes the probability. So when we look at this equation in the long run, we get the following, that the average winnings per game in the long run is the probability of heads times minus 3 plus the probability of tails times 2. So all we did here was we took the relative frequency and we said that in the long run that becomes probability. So this is an important idea. So we've shown that in the long run the average winnings is the probability of heads times whatever we win with heads, which is minus 3, plus the probability of tails times whatever we win with tails, which is 2. So really what we've done here is this thing here is called the expected value. So I should put in here that this is in the long run. So the average winnings per game in the long run is the expected value. And we've shown how to work it out here. So now what's the probability of heads? Well, the probability of heads is a half. And we have minus 3. And the probability of tails is a half times 2. And let's work that out, and we get minus 3 over 2 plus 2 over 2, which is minus a half, or minus 0.5. And that's what we saw happening in the Excel sheet, that in the long run, the average winnings per game tended to be around minus 0.5. Okay, so what we've done here is one particular example of working out the expected value. I'll finish the lesson by writing down the general formula. And here it is. So in general, if we're carrying out some random process and the outcomes have values, then this is what we mean by the expected value. It's the probability of the first outcome times the value of the first outcome, plus the probability of the second outcome times the value of the second outcome, and so on. We keep going through all the outcomes and we do this. We just take the probability of the outcome and multiply by its value, and then we add all of these things up. So this thing, when we work it out, we call it the expected value. And if you look back at our example, that's what we've done here. You see, the average winnings per game was the probability of the first outcome, which was heads, times the value, which was minus 3, plus the probability of tails times its value, which was 2. So this was just a special case of the expected value calculation. So this formula here looks complicated, but in later lessons we'll do some examples and we'll see that in practice it's not that hard to use.